Now let us see these two examples. Design a DFA for the strings with 3 consecutive zeros and design a DFA for the strings without 3 consecutive zeros. So let us solve the first example. So we have to design a DFA for the strings having 3 consecutive zeros. So first let us design the language. So L is equal to, so the minimum string is 000. So before 000 we can have any number of zeros and ones. After 000 we can have any number of zeros and ones. Let before 000 we have a single one, and after 000 we have 1. Let us take one more string 000. So before 000 we can have any number of zeros and ones. After this 000 we can have any number of zeros and ones. So after this 000 we can have any number of zeros and ones. So this is the language. Now let us construct the DFA. Here the minimum string is 000. So length of 000 is 3. So we require 3 plus 1, that is equal to 4 states. So let the states are Q0 to Q3. So let the initial state is Q0. Next state is Q1. Next one is Q2. And the last one is Q3. Here Q3 is the final state, whereas Q0 is the initial state. So what is the minimum string? 000. So Q0 on 0 means Q1. Q1 on 0 means Q2. Q2 on 0 means Q3. Okay. Next, DFA means we have to apply input alphabet symbols on each and every state. Here we have 0. So that means input alphabet contains 2 symbols, 0 and 1. So we need to apply 0 and 1 on each and every state. On Q0, 0 is applied. So we have to apply 1 on Q0. On Q1 also 0 is applied. So we have to apply 1 on Q1, 1 on Q2. And on Q3, no symbol is applied. So on Q3, we have to apply both 0 and 1. Here before 000 we can have any number of ones, so there is no constraint on that. So let us apply 1. So Q0 on 1 means Q0 only. Next here these 3 are 3 consecutive zeros, so we can't apply one transition as a self loop. So Q1 on 1 means we have to go to the Q0 state. Why? Because after 1 there is a possibility that we may have 3 consecutive zeros. Next on Q2 we need to apply 1. So here also we can't apply a self transition like this. Why? Because these 3 are the consecutive zeros. So if we apply 1 on Q2, then we need to go to the starting state. Why? Because after this one we may have multiple zeros. Next we need to apply 0 and 1. So let us apply 0 and 1. So after these 3 consecutive zeros we can have any number of zeros and ones. So there is no problem on this. So 0 and 1 means Q3. Okay. Q3 and 0 and 1 means it will goes to the Q3 only. Now let us check whether our diagram is correct or not by taking some input symbol. Let us take this symbol. Let us take this input string 1000111. So first, what is the initial state? Q0 is the initial state. So what is the first symbol? 1. So Q0 on 1 means Q0 only. Next we have to apply 0. Q0 on 0 means Q1. Next Q1 on 0 means Q2. Next Q2 on 0 means Q3. Next we need to apply, here we have 2 ones. So Q3 on 1 means we will stay at Q3 only. Q3 on 1 means we will stay at Q3 only. Here what is Q3? Q3 is nothing but final state. So we can say that our string is accepted by the DFA. So our DFA is correct only. Now let us see the second example. What is the second example? We have to design a DFA for the strings without 3 consecutive zeros. So without means we have to simply make final state as non-final state and non-final states as final state. Here we have one final state, that is Q3. So we have to make this as non-final state, whereas make Q0, Q1 and Q2 as the final states. So here Q0 is nothing but what? This is non-final state. So now if we want to design a DFA without 3 consecutive zeros, what we have to do? We have to make this as Q0, Q1, Q2 are non-final states. So let us make those 3 states as final states. Next, Q1 will also become final state. Q2 will also become final state. Next here, what is Q3? In this diagram, Q3 is final state. So we have to make this final state as non-final state. So non-final state means we have to write only one Q3. Okay. So next, transitions are same only. So 1, 0, 0, 0, 0 and 1. So 1, 1. So in the first diagram, what is the initial state? Q0 is the initial state. So here also Q0 will become the initial state. So here Q0 acts as both initial state and final state. So what is the difference here with 3 consecutive zeros and without 3 consecutive zeros? Without means we have to draw the DFA for with 3 consecutive zeros, and we have to convert that as without 3 consecutive zeros by converting final state into the non-final state and non-final states into the final state. Here the final states are Q3 is the final state, so that is converted to the non-final state, whereas Q0, Q1, Q2 are the non-final states, so we have to convert them as final states. So Q0, Q1, Q2 is the final state. Here in this diagram, Q0 is the initial state, so here also Q0 will become the initial state, and the remaining transitions are same. There is no difference between the transitions. Q0 on 1 means Q0 only. Next, Q0 on 0 means Q1. There is no change on the transitions. So in this way, we can design a DFA for the strings with 3 consecutive zeros and without 3 consecutive zeros.